of a resistor. One is what? Area. 2, length. 3, resistivity. 4, temperature. Then you need to now know that resistivity is equal to 1 over conductivity. Resistivity is your rho. Conductivity is your sigma. Something that has high resistance, we have low conductivity, and something that has low resistance, we have high conductivity. So it's a direct thing. But you need to know the symbol, the unit. What's the unit of resistance? Resistance is ohms, and you know that from here, R is equal to rho L A. That means that rho, what will be the unit for rho? That's RA over L. What's R? Ohms. What's A? Meter square. What's L? Meter. Meter cancel meter. That gives you what? Ohm meter. So the unit of rho is ohm meter. And the unit of Siemens would be ohm meter. And that is called Siemens. So the unit of conductivity is Siemens, and the unit of resistivity is ohm meter. It's another question they can ask you. It's a great error. And we spent huge money on this. The day I wanted to fix it, one is 400 and something thousand. When things were still cheap. And I just dropped money. Only to come back and none of them is working. Even all the ones inside the room are not working. Which electrician. So, can we go on? We are through its resistance. Dr. Mike. I don't know you are the one that is bringing it. What you wanna So this is Dr. Michael, a medicine and surgery student from the University of Ibadan. He's currently 200. Are you doing it? Okay, is this session? The first time you want to send this in 300. So So it's popularly known as the creative doctor. One of those channels. Michael used to sit around the front and him and let me give him. They'll be holding my neck like this. So thank God, I'm just seeing him. And he brought maybe his younger one to come and achieve greatness too. So I'm just saying you should say hi to him. So he's a true man of God. A true man of God. So I see who you like it. So we do advise, some people have chosen medicine here, we do advise them to go for medicine. Or they should go back home.
What advice to go for medicine? What advice to go for just go for what you
Is medicine tough?
I can't say yet because I've not fully started. But based on what I've seen, it requires ruggedness.
One has to be very strong.
Very, very strong.
Have you seen Cadaver?
I saw Cadaver today.
Today?
You seen Cadaver? He's not playing with my money now.
So, that's what I said. interesting? So are you enjoying it? Or if you are given another choice, will you leave medicine? I just want you to learn, oh, that's why we're asking this question. So if you are given another choice, will you leave medicine or probably go for another course?
I've been enjoying it because I just so definitely have to enjoy it. I just have to make it interesting for me and just make the journey interesting. I know the journey is tough, but I just have to make the journey interesting for myself. I chose it definitely, so I have to continue.
Even before I don't know, I just want to ask this. Before you got the medicine, did you face any challenges or everything just went smoothly? You got the medicine, how many jams did you write? 3 UTM. But you only wrote 2 I. So, due to time, I would have allowed him to talk to you. But I don't know if he has anything to say generally. If he has anything to just talk to you generally. When you see him on campus, those of you going to know and we definitely meet with him. At some point, I don't always see him on campus, he's my senior, so we don't see. So at some point we meet him. Michael,
I really have much to say, but I just want to say one quote I used to tell myself. One quote I used to tell myself when I was praying, and I still tell myself. So what I want to say is one quote I used to tell myself while I was praying, and that I even used to tell myself till now is if I put my mind to it, I will definitely get it. I've got challenges that will make me feel like, okay, I'm not really good enough, but I notice that it's what I spend most of my time doing that I definitely don't good at. So those that are abroad, students that are abroad, international students, you have sweat, you have two brains. They're just like God. So if I just put my mind to it, definitely I'll get what I'm. That's just that.
So you have to set your mind to it. If you set your mind to it, you will achieve it. And that's what he has said, that you should be determined and God will be with you. So Michael, thank you so much. God bless you. Good to see you again. I'm still calling. I'm almost coming up. So there are more than some questions we have asked for. Due to time. So your dream is valid, your dream is achievable. You are the one to stick to your dream and understand what you want. There is nothing you want to become in life that you cannot become it. There is nothing. Just make up your mind and start fighting for it. So then I think you are through with resistance. There is nothing else to know. The combination of, is there anybody that does not know combination of resistors here? I'm not going to say much because of those that I still want to talk with them. Let me just quickly round it up. So for combination of resistance, you can also connect resistors in series. I'm not going to derive this one for you. And you can also connect resistors in parallel. When you connect resistors in series, you know what that means. When you connect resistors in parallel, you know what that means. Right? We did it this morning. So you know the difference between series and parallel. But the difference between this and that one we brought in the morning. Now, if current is flowing through this guy, current is coming from the cycles. Is it different currents that will pass through them? It is the same current. I1 will be equal to I2, Abi, and will be equal to I2. Is it the same voltage or different voltages? So your V1 will not be equal to V2 and will not be equal to V total. So you get. but your V total will be equal to V1 plus V2. That's when we say 4 plus something the other time, and we got 12. Remember, 4 plus 8, so the total is always equal to sum of these two. You still remember that now?
Yes.
So when you connect resistors in series, effective resistance is always given as R1 plus R2. It's opposite of capacitors. If you derive it yourself, you will get this. So when you connect them in series. So when you connect them in parallel, which means that when you connect them in series, R effective is going to be greater than R1 or R2. Ready? So then when you connect them in parallel, your current will not be the same. Ready? You can tell now, the current can't be the same because at junction, if this is the total current that is coming, then this can be divided I1, I2. So your I total is going to be I1 plus I2. That's Kirchhoff's first law. At that junction, the current will divide. So now, they will not be the same. Current flowing will not be the same. But your I total will equal to I1 plus I2. But since they are connected in parallel, we did it in the morning, their voltages will be the same, and the V1 will be equal to V2, and that will be equal to V total. All of these things will be applied in solving questions when you are dealing with them. Then 1 over R effective is going to be equal to 1 over R1 plus 1 over R2. So at the end of the day, your R effective is going to be less than R1 or R2. Is that taken? So that's all you need to know for combination of resistances. We can solve questions on that. And same way you did product and sum, you can also do product and sum for this one. So now, what you asked last year on potentiometer, so you need to quickly know. When you're talking about, we have what we call a Wheatstone bridge and a meter bridge. We can talk about that maybe later if you want to. And potentiometer as well. For Wheatstone bridge, because we are supposed to have depth this class for junior ones. So your Wheatstone bridge is used to determine unknown resistance. So we use Wheatstone bridge to determine unknown resistance. Sure you get. The Wheatstone bridge is built like this. So now, if you have this is your Wheatstone bridge. This is, let's say this is Rx, that's the one you do not know. You know R2, you know R3, and you know R4, but you do not know Rx. And there's a voltage of this battery. It's something that we can break down and we start calculating and know. But before your Wheatstone bridge works, just know that there must be no current flowing through the galvanometer. Galvanometer must be zero deflection. So galvanometer shows no deflection. So they can ask you that. So your galvanometer must show no deflection to show that this guy is working perfectly for you to get what you are supposed to get. So how do you calculate the resistance? So the resistance will be Rx over R2, which will be equal to R3 over R4. So the ratio will be the same. That's how you use the formula. Just do this over this and this over this. Do not ever do this over this. Don't ever. Don't do this over this and this over this. Do this over this or this over. Just go sideways, not across. So you can do Rx over R2 and R3 over R4. If we derive the formula, that's what we get. But we don't have time to start deriving it now. So Rx over R2 is equal to R3 over R4. That's how Wheatstone bridge works. So you use it to determine unknown resistance. Then we have what we call a meter bridge. A meter bridge is just an application of Wheatstone bridge. We also use it to determine resistance, but in relation to the length of the wire. Can I rub this part? I just want to quickly end everything electricity. Sorry, I'm taking your time. So by tomorrow, I have exam tomorrow, so on Friday. So you let me know which one you want to do between lenses and magnetism on Friday. Lenses. So we do everything lenses on Friday. At least, have you done lights? Introduction to lights?
No.
Light energy?
No.
Have you done sound waves?
No.
Have you done properties of waves?
No.
So lights. So on Friday, we talk about light energy. We talk about reflection of light at plane surfaces, reflection of light at curved surfaces, optical instruments, refraction. That's a whole lot. I'll see a way that we can complete it on Friday by God's grace. And that'll be all on lights. I want us to finish everything we have to do. Just for you to just go and be solving questions. So now, what's the next thing we need to do for meter bridge? So meter bridge is a practical application. It's an application of Wheatstone bridge. So it's an application of Wheatstone bridge. Your meter bridge, your meter bridge has something like this with a jockey and a wire, then another resistance, then connected across the battery. So it's just like that. So you know that R is directly proportional to N. If you go back to R is equal to N over A. So R is directly related to if I hold the area and resistivity constant. Since this wire is the same material of the same area and the same material, resistivity, the only thing I can be changing is length. So if I keep changing length, it can be affecting the resistance. Sure you get? So now, let's say from here to here is N1 and from here to here is L2. So it's the same thing. Just say Rx over N1 is equal to R over L2. That's how you use this one. It is now for you. Sometimes this resistor might be in parallel too. Let's say R3. In this scenario now, that means you first find out total here. Turn the parallel to series, adding, and you do this. You get that? Now you get your R total now for parallel. So you get the R total when they are connected in parallel. So that's Wheatstone bridge. Potentiometer. Potentiometer is used to determine EMF. So to determine the EMF of a battery, you use a potentiometer, and you use it to determine it accurately in place of a voltmeter. Like I said, you are going to have a cell which probably we call the primary cell. It's going to be connected across a wire at a point. This EMF, this wire is more like the resistance of the same length. Since R is directly proportional to N, I can say the length from here to here is my R. Just like if I say this is the resistor now, we are no longer talking about resistor because the wire has the same material. So the area is the same, everything is the same. So this EMF balances this material from here to here. So I can say my, V is equal to IR, abi? So I can still say that my E is equal to IL. Like if R is L and all of those stories. But let's leave that. Now, you now do something. You connect it to another EMF. Yes, I did not tell you connection of EMF. Now you connect it to another EMF. This one EMF you know, and you know the length of the wire. So then you connect it to another EMF E2. So in order to determine the EMF of this battery, you just keep changing the length using this jockey until I the galvanometer is 0. So when the current in galvanometer is 0, that means this guy balances this and this guy balances this. The ratio balance out. I could have expressed this further, but just know that before your potentiometer will work, there must be no current in the galvanometer. It must show what we call no deflection. But if it had been voltmeter, you know it would have drawn current. But for galvanometer, it's designed that way. I mean for potentiometer. So at the end of the day, you can just say since E is direct proportional to L, just like E direct proportional to R. And I think this answer that lady's questions again, that potential is direct proportional to resistance depending on the condition. So you can have E1 over, let's say from here to here, it's L1. From here to here is L2. So you can say E1 over L1 is equal to E2 over L2. So this is the formula to solve for the EMF. So the first part here is called the primary EMF. Primary cell. Why this part is called the secondary cell. So the ratio of E2 over L2 here balances the ratio of E1 over L1 here. And this is what you just need. But sometimes you need to understand our principles so that you'll be able to apply them when some questions are looking tricky. Only questions that came out on it last year was a direct question. You just apply this formula and you get to answer. So that's about current electricity. But there's combination of EMF that you need to know. You can have several cells connected together. Your cells can be connected in series, not this so, and your cells can be connected in parallel. I hope you are still following. Your cells can be connected in series and your cells can be connected in parallel. So you can take a connection like this. So all of these cells now, let's say this is E1, E2, E3. You know we said with I going to be Q over T. So that means this is going to be equal to what? IV. So power is equal to energy per unit time. Energy is equal to QV. So QV. Q over T is current and multiplied by the potential. So T they generate heat. Abi. So in that case, now they generate heat. Energy is equal to power times time. Abi. And what is energy? It is more like heat, which is equal to power I square RT. So Joule's law of heating told us that the heat generated by these appliances is directly proportional to the square of the currents, is directly proportional to the resistance of these materials, and is directly proportional to the time of usage. The more you use it, the more you get the heat supplied. And all of those things. So the heat you get depends on the resistance of the material. So we call that Joule's law of heating. And that has an application that you use to heat your water, boil everything you want to boil. We still use it like generator. Then boiling. So that's another application, heating effects. There's chemical effects, there's magnetic effects, and all of those things. Another application is, you are not through with this. Am I too fast? I just want to end everything at left, so that it just end everything. I know you are hungry, you are tired. Can we talk about the next? How do you buy electrical energy and power? In order to buy electrical energy and power, then energy is sold to you. All this electricity we are using now, if NEPA come tomorrow, KTN, you are going to pay for everything. So in order to pay for it, they will calculate the power rating of all the things I'm using and for the amount of time I've used it, and they will tell me my bill at the end of the month. So, but do we do that in Nigeria?
No.
NEPA just show up at your doorstep. You have used 120,000 naira this month. Ow! I was not even at home all through the month. I didn't even work. But you have used it. You don't care. So they should calculate everything you have used for the month and tell you to pay for it. So we measure it. Please know the units of commercial units. The commercial unit is kilowatts hour, not per hour, kilowatts hour. You pay for everything in kilowatts hour, not per hour. Share you get. So depending on what you have now used in your house, you can continue to pay. Just calculate the total power together. If this bulb is 1,000 watts, that one that fan is 2,000 watts, this one is 300 watts. Add everything together, divide it by 1,000. That gives you the power in kilowatts. Then multiply it by the number of days you have used it in hour. Then if they now tell you that 1 kilowatt hour is 10 naira, multiply it by that 10 naira. That's your debt for that month. So that's how we do it. You can, so this high and I can go. So this high and I can go. So efficiency is equal to R over R plus R multiplied by 100. So they can say you should calculate the efficiency and they will give you resistance and that. That's another formula you use. If you are supplying your house electricity, power transmission, electricity is supplied to your house at high voltage and low current. So that's power transmission. All of these things are reason. We'll talk about them on magnetism. We'll talk about it on magnetism. So at the end of the day, we have most of your appliances can use some plugs, some circuits. Remember, in your house you have a live wire, you have a neutral wire in your plug, you have a heads. What's the color of live wire? It is either red or brown. Your neutral wire. So your head is usually yellow. So they can ask you any of these things, colors. Then fuse and circuit breaker. Fuse and circuit breaker, they prevent surge, so they help you to prevent sudden surge. So there's a way fuse work, but just know that these guys are connected to live wire. So we'll still talk about these guys again, especially this aspect. We'll still talk about it again because I just have to say it just to round up the entire class that we started since morning. So today I want to believe we have covered all the important parts in electricity. So the remaining parts, this and because these are the aspects I didn't really explain anything, but I just quickly brushed through it for revision's sake. So, but we explain it better later. So the remaining parts of your Kirchhoff's law, how you do electric potential when you put two charges together, but more than 2 charges and all. For the OAU people, we'll do them again. So when I come around, we'll still do them again. But for now, let's just brush through everything so that we know that we are left with. So on Friday, we'll see. We can quickly talk about lenses on Friday. Since you have done make this, please practice. You have done, so you will continue some parts of waves. So I will not have to talk about that again with Mr. B. Factoria. Then Mr. Ola can still continue. So he might still do this part again to make it better. Then by next week we'll do magnetism. Then the other teachers will do atomic physics. So that will be all. So I'll see you guys. So please make sure you subscribe to our channel. We'll see you on Friday. Like and comment. What do you think about today's class? Like and comment. Let us know what you think. Subscribe so that you get updates on our subsequent classes. We share money too. We'll see you.
Please see us soon.